All right, so we have, this is activity 5, functions and function notation. All right, representing relations and functions using tables and diagrams and graph. Identify relations that are functions. All right, so use the machine to answer the questions below. All right, so again, this book came out 2014, so that means these movies are like 2012, right? So we have the Hunger Sports, copyright, right? You can't really use the actual names of these things. Hunger Sports, you have The Revengers, Battle Sales. Do y'all remember what movie that is? Yeah, Battleship. All right. We have Sold Out. Y'all remember what movie that is? Yeah, good call. It wasn't really a movie. It's just it's actually sold out. There's not any in there. Okay. See, even these type of things, even these movie machines, right? These are still kind of foreign to you guys almost now as well. Because see, the big thing was that this represented like the red box machines, right? And does anybody even still use red box? The red box getting DVDs and stuff, right? I mean, we only really used red box. It was whenever we would go on like trips, so that way we could have DVDs and we'd have a DVD player, you know. But I mean, now with unlimited data, you know. But anyway, what about the Amazing Insect Man? Yeah, the Amazing Spider-Man, right? We have already moved on. There's now a third Spider-Man now, right? And apparently Spider-Man, the new one, Spider-Man 3 that's coming out, is going to have all the old ones in it. So I look kind of forward to that. The Dependables. The Incredibles. No, the Dependables. That's the I'm trying to think of what it is. That's the movie that had like all the old actors from the '80s in it, like Sylvester Stallone, Arnold Schwarzenegger was in it, and the guy that was Ivan Drago and Rocky and Expendables. The Expendables. The Light Knight. Excuse me. I do not like the way you said Batman. Do it again. There you go. All right. Yeah, exactly. The Light Knight is the Dark Knight, right? Because I'm Batman. All right. Come on, Kaysen. You know you want to do it. Come on. This is going on YouTube. Come on, Kaysen. No? Okay. I'm Batman. Good job, Kaysen. All right. So here we go. What DVD would you receive if you inserted your money and pressed A1? Hunger Sports. C2. C2. I'd get the Light Knight, right? B3. I'd get the Amazing Insect Man. Okay, do not forget the amazing part. All right. Assuming the machines were properly filled, what happens if you would press the same button twice? You should receive 2 identical DVDs, right? If I push the same button twice, I should get the exact same DVD, right? I should get the exact same DVD, right? So if I push this twice, I should get the exact same DVD, okay? So if I push this twice, I should get the exact same DVD. In the DVD vending machine situation, right, does every input have an output, right? Because every time you press a button, which that's an input, you may receive a DVD, which is an output. In the vending machine situation, does every input have an output? Raise your hand, tell me what you think. Yeah.
Yes.
Okay, explain your reasoning.
Because it can't be a function without an output.
Okay, well, take a look here. We're talking about this machine.
Oh no, it's sold out.
If I push this if I push each one of these buttons, which is an input, will I get an output? Okay, so I have yeses, I have nos. Those of you that says no, why do you say no? Raise your hand.
Because if it's sold out, you won't get it.
All right, so you're saying if I push which one?
B1.
So if I push B1, right, I'm not going to get anything. Okay. Yeah. Right. So the answer is no, right? Because B1 does not have an output since it is sold out. Right? It doesn't have an output since it is sold out. All right, so number 4, each combination of an input can be expressed as mapping. All right, written as an input, draw your arrow to the output. For example, B2, draw your arrow, Amazing Insect Man. Write as mappings each of the possible combinations of buttons pushed as the DVDs, right, received in the vending machine. Okay, so I'm not going to scroll it up because I don't want you to see the answer for say. So I'm gonna just do one right here, right? So I'll have, for example, I'll have A1. And A1, I'll draw my arrow. You'll do a much better job. And it's going to give me what? When I push A1, what am I going to get? I'm going to get Hunger Sports, right? And then whenever I push A2, I'm going to get what? The Revengers. All right. So you go ahead and do that. All right. So A3, what do we get for A3? If we push A3, we get Battle Cells. Remember, this is SpringBoard, right? SpringBoard Harmony likes you flipping back and forth. They want you flipping the page back and forth, okay? So do A3 is Battle Cells. All right, look, I'll help you out just a tad bit. Let me clear the screen here, move this. Here you go, I'll help you out just a tad bit. There you go, so that way you don't have to flip back and forth as you are doing number 4. And then B wants you to create a table to illustrate how the inputs and outputs of the vending machine are related. Okay, so for B, create a table. All right, so for B, we're now going to create a table. What's going to be in our first column on our table? What do we have to do, right? In order to get a movie, what do we have to do first? We have to push a button, right? So our input goes first. And then in the second column will be our outputs. All right, here is what the mapping should look like. Here is what your, keep working on your table if you haven't finished your table. Here's what the mapping should look like. If you're watching the video, you're going to need to pause it. All right, and so B says to create a table to illustrate how the inputs and outputs of the vending machine are related. All right, so there is what your table would look like. Note, right? Again, like we said previously, the B1, it's not on your mapping, but it is on your table. Okay, so for your table, it does have to be represented. All right, if you're watching this, you'll need to pause it. All right, so mapping, right? Mapping relate values from one set of numbers to another of numbers can be written as ordered pairs. All right, ordered pairs show the relationship between two elements written in specific order using parentheses notation and a comma separating the two values. A relation is set of ordered pairs, right? A relation is the information that can be represented by a set of ordered pairs. Relations can have a variety of representations. Consider the relation 1/4. All right, 3, and 6/5. Seen here are a set of ordered pairs, right? Seen here are a set of ordered pairs. So these are sets of ordered pairs. The relation can be represented by these ways. I can take these ordered pairs and I can put them in a table, right? Just like what you've done. I can take these ordered pairs and I can put them in a mapping. And just like you've done in previous grades, I can take these ordered pairs and I can put them in a graph. Okay? So if they give you, like number 5, if they give you a set of numerical mappings, write them as ordered pairs. Number 5, right? So they give you a set of inputs and outputs. It wants you to write them as ordered pairs. All right, so we would have input 1, outputs -2. The ordered pair would be 1, -2. Input 2, output 1, ordered pair would be 2, 1. Number 3 and 4 would be 3, 4. And 4 and 7 would give me 4, 7, right? As a set of ordered pairs. Okay? So what I would like for you to do is I would like for you to do number 6. Okay? I'd like for you to do number 6, if you would. All right, I'd like for you to do number 6. Okay? I'd like for you to do number 6. All right, so number 6. Vending machine at the Ocean Road and Air Show creates souvenir coins. You select a letter and a number, and a machine creates a souvenir coin with a particular vehicle imprinted on it. The graph shows the vending machine letter number combinations for different coins. All right. So make a table showing each coin's letter number combination. All right. So for the boat, all right, for a boat, we get A5. For a train, we get B2. For car, we get C4. For bus, we get D1. And a plane, we get E3, right? For the boat, we get A. There's your input. Output would be 5, right? For the train, B2. Car, C4. Bus, D1. Plane, E3, right? So that's how we got that. Now, using that table, we have to write the letter and number combinations as a set of ordered pairs. So we would have this. All right, so the brackets represent a set. The brackets represent a set, letting you know that this isn't like an infinite set or anything like that. This is only these specific values are the only ones that can be in this solution. So that's why they have brackets around it. Parentheses indicating that it is an ordered pair. So you have A5, you have B2, C4, D1, and E3. And then writing these as a mapping, if you notice, take a look. If you notice at the top, right, of page 67, you notice that the mapping, right, is that you put all your inputs in one circle and draw lines to their matching output in the other circle. All right. Generally, you would have these in order as well. These would generally be in order from least to greatest or something of that nature. They would be in order So like these inputs here would actually be a 3, 4, 5, and the lines would be kind of crisscross. All right. So what you would typically see, like I said, you would see like this. You'd have the mapping, but this would be 3, 4, and 5, and so the lines would be kind of like this. That's typically what you would see, okay? And the lines would be crisscrossing. That's fine. It's still a function as long as it has one line going from an input to the output. It wouldn't be a function if I had something like this, right? Where one has one line and, going to the 4 and 5. That's one input giving me two outputs. So no, that wouldn't work. All right. So what does the mapping look like for number 6? It looks like that right there. Okay. All right. And that is lesson 5-1, Algebra 1 Springboard, numbers 1 through 6.